Let us try some examples for this module. First example, determine the polynomial of arbitrary degree n that fits the data points. We have 11 data points. This can serve as x, this can serve as y. So sometimes we call x as the independent variable, and y is the dependent variable, meaning y is dependent to x. Okay, so our goal is to find what degree m can fit the data points best or well. Okay, so we have here the sample code to solve this one. So we have encoded the points x data and y data, and then we'll try to so first you input. You can actually try running this one. Okay, so you will input one, and then let's see if we can run this one. Okay, so we first, sorry, I think there's a problem. Okay, so we have not run this one first, so let me run this again. Okay, so I suppose we can. There's also a data, also need to run the state. Okay, so having run all these user-defined functions, we can go back here. Okay, we'll look at the polynomial linear. So the standard deviation of the linear equation is 0.511. How about the second degree? 0.31. How about the third? Also 0.31. 9. So, and then let's try the fourth degree. Okay, so you have 0.34. Now our goal is to find the degree polynomial m. So here we can choose third degree because we have the smallest, second degree polynomial, which is 0.3109, smallest among the four. You can proceed to 5 and so on, but it's not so practical. So you can choose among the first four. Okay, so since the second degree or the quadratic equation has the lowest standard deviation, we have the quadratic function. So this quadratic function is considered to be the best fit. Okay, meaning that this line quadratic function can represent the data well. Okay, so we can verify by plotting. So I prepared some of the plotting code here. Okay, so this is the data points. So if you notice, you can actually put a straight line. Okay, so first we have the m is equal to 1, so this is a linear line. Okay, actually it can represent the data points, but if you look at the quadratic equation, I think it's much better. But some would choose the linear one because its linear equation is very simple, and yet it's not prone to deviation. So sometimes people will choose linear over quadratic in this case, but there's some data points that better quadratic than linear. So it depends on the application. So in this example, the datas are not there's no label, or it doesn't talk about something. But if it talks about a linear relationship, then we can probably use the linear equation. Okay, and then you have the third degree, okay, which is close to quadratic, and then you have the fourth degree. Okay,